Hello guys, hope you are doing well. Today we are going to discuss the problem combination sum 2. So what is the difference between combination sum 1 problem and combination sum 2 problem? So as we have already solved the problem combination sum 1. So in the combination sum 1, the candidate array has no duplicates element in the array, and here it is given like uh, there are there are duplicate integers, there might be duplicate integers in the array. So let's jump into the problem first. So the combination problem 2 is stated as: given a collection of candidate numbers and a target number, find all unique combination in candidates where candidate numbers sum to target. This problem is like you are given an array and a target integer, so you have to find the unique combinations from that array, so that the sum of whole combination, sum of each individual combination is equal to the target. And it is also given that this array only contains positive integers, and solution set must not contain duplicate combinations. Okay, and but array might have duplicate numbers. In first problem that we have solved combination sum 1, that already we have solved like this problem combination sum. So in this problem, when we are solving, it is given that array doesn't contains any duplicate. It is given an array of distinct integers. Okay, so we have solved that problem already. In combination sum 1, there might be duplicates because it is given 1 and 1. Okay, so there are duplicates. So how we are going to handle that duplicates actually? So here, as we have already done in combination sum 1, so there we have two possibilities. We can include for particular integer in our solution set, or we can exclude that integer in our solution set. But the problem is like here we are having multiple instances of the same integer. So one thing we have to note it down here, that if we are excluding any particular element, then we have to exclude all of its occurrences. And it is also given that each number in the candidates may be used only once, and it was given in the previous that that number can be used multiple times, unlimited number of times. So what we are going to do here, like if we are not going to include any integer in our solution set, then we are going to like exclude or ignore all of its occurrences in our solution set. Okay, and if we are going to include, then we have to include it and still increment the index. Previously we are doing like previously we are doing, yeah, previously you can say like, uh, whenever we are including this element, still we are having idx at the same position if you are including it. Okay, but in this problem we are supposed to include it only once. So after including it, we have to include the next element, not this current element again. And if we are not including this element, then we have to ignore all of its occurrence. So how we can ignore all of its occurrence? Like we can sort this candidate array so that all the occurrences of a number are come together, so that it is easy to ignore actually. So we will proceed toward this problem in similar manner. So let's see how we are going to do this problem. So first we will create a return array, like let's say it is answer. So new array list. Okay, so this is our array list, and let's say we have created an array nums. So this dot nums equal to candidates. Okay, and let's say this is given us to us, and let's create an candidate array list. Let's say cand new integer, and we will try to solve it recursively as we solved the combination sum problem. So we pass it here like zeroth index. We are starting from zeroth index, and we have to make target, and let's say candidate. Okay, and in the end we return that answer. So let's write the function solve int idx int target list integer candidate. So this candidate is like one combination of numbers that are going to sum to target. So we'll check here if our target reduces to 0, means we are able to get a combination of numbers that is sum to target, because we are going to, whenever we find a number, we will try to subtract it from the target. So we'll add it to our answer. And simply return. Otherwise we'll check if we have reached the end of the candidate array, then there is no element to explore. We just return. We'll simply return. And now there are two cases, like first we include the element or we exclude the element. So as we already discussed, if we are supposed to exclude the element, then we have to exclude all of its occurrences, and we have to sort the candidate array as well to make the all occurrences come together. Candidate, we have sorted the array, so all the occurrences of a particular numbers came together here. Now let's try to find, let's take an integer I that is equal to idx plus 1. So we'll try to find a different number. So if we are to exclude that number, exclude the current number, then we have to start the new recursion from the number that is different from the number current number actually. So we will try to find that number here. So while I is less than nums dot length and nums idx equal to nums I, will simply keep on incrementing I, and after we have found that index of that element which is not equal to the current number, that we will use in excluding the current number actually. So first we will use this number if it is usable. So let me check if target is greater than or equal to nums idx, then we can use this number. So we'll add this number to candidate array and call the function recursively solve idx plus 1 target minus nums idx and candidate, and after that we simply backtrack. Size minus 1, and this is the second case. We are including the current element under consideration, and that too only once. So idx plus 1. Here we are excluding uh, current number. So we have to exclude all of its occurrences. To exclude all of its occurrences. So this recursion goes from I actually. I, and we are not including this element, so target remains target, and our candidate array list would remain candidate. No modification in that. So let's try to run this program. Yeah, so answer is correct. Let me check for one more case. So it is giving me correct result. Let's submit this. So yeah, it is successfully accepted. So hope you have enjoyed this video and got the difference between combination sum 1 and combination sum 2. These are very important problems. As you can see, this problem has appeared in many of the product based company. You can see here. This problem has appeared in Facebook, Amazon, Bloomberg, eBay, Microsoft, Google, Nutanix, and Uber, LinkedIn, Apple, and Walmart Labs, and Snapchat. So this problem is very important, and these two variants are very important actually. So you have to identify that when we are using duplicates and how we are using duplicates, so that combinations would be different actually. You are not allowed to use same combination again and again. So hope you have enjoyed this video. Thank you for watching. Do subscribe my channel for more videos like that. Thank you for watching.